Welcome to Talk+Water, the podcast that takes a deep dive into the world of water with those making waves. My name is Todd Votteler, and I'm your host for Talk+Water. I'm also the editor-in-chief of Texas+Water and the Texas+Water Journal. You can sign up for Texas+Water by visiting texas+water.org, and you can sign up for the Texas+Water Journal at texaswaterjournal.org. Both publications are free. My guest today is Dr. Emily Fairfax, who is an assistant professor at California State University, Channel Islands. Dr. Fairfax's current research is focused on beaver dams and their hydrologic and geomorphic impacts. Emily, welcome and thank you for being part of Talk+Water.
Thank you. I'm super happy to be here and chat with you.
Great. So let's start out with your background in water. How'd you first become, involved with water or kind of made it one of the things that you focused on in your career?
Well, water has always been something that I've enjoyed. I can think all the way back into elementary school. We would take these field trips out to like marshlands, and I was living in Indiana at the time, so the water situation wasn't necessarily the most scenic, but it was so cool. We'd go to these sort of example wetlands, and I'd see the turtles and the cattails, and it was just so different than what I saw back in my neighborhood, which was mostly corn. And I thought that was amazing. Like, there's so many things here. And it kept growing from there. I was a Girl Scout, and every time we'd go camping, I'd immediately go find the creeks and just start combing through them, seeing what I could find. Could I find cool rocks? Could I find cool plants? I found crawdads, and I thought that was really cool. And it was just so fascinating, but I didn't really know you could have a career in water. And so after like all of these wonderful transformative water experiences, I went to college and studied physics and chemistry, and I had no idea what I was going to do with that. But I kept gravitating towards water, and I led canoe trips one summer up in the boundary waters of northern Minnesota. And that was the first place I saw beaver dams, but I wasn't even thinking about studying them at that point. I just wanted to get back outside and try to be around water more, because it really was what made me happy.
So you just recently published some really interesting research, and we'll get to that more specifically here in a little bit. And that research has to do with beavers and their impacts on fire and riparian areas. But I'm curious, did you start out doing your research kind of like focusing on riparian ecology or fire ecology, and then kind of that led you to focus more on beavers, or was it kind of the other way? What's the chicken and egg scenario here?
I feel like it was neither the chicken nor the egg. I went and I was doing material science and weapons system engineering after college. And that's what my job was. And I was seeing how different steels would strain under different conditions. And as soon as I got off of work, I'd go to the creek and go fishing and try to get out back into the water. And I was realizing at that time, like, I don't think I want to be a materials scientist or a systems engineer. What am I going to do? And I was sitting on my couch watching PBS, and a documentary called Leave It to Beavers came on. And it's so good.
Yeah.
It was mind blowing. And the way that it was set up was really impactful for me, because they kept saying, like, there's so much we don't understand about this. Beavers are moving back into deserts and drylands, and we're seeing these huge green oases pop up, and we don't know how or why or how long, or like, what's the effect of this on the rest of the ecosystem. And they're interviewing all these strong female hydrologists, and they're just saying, like, we have so much more studying to do. This is a job. And I was like, this is a job. And so I quit my actual job and went to grad school to study beavers. I was hooked.
That's great. So where'd you go to grad school?
I went to grad school at the University of Colorado Boulder, and I studied geological sciences there.
Okay. Great place to study geology up there in the mountains.
Yeah, absolutely beautiful. Lots of local field examples.
So, I had kind of experiences off and on with beavers growing up. And I can just recall that I went fishing in Alaska with my brother and my dad in the late 90s. And we went up the Alagnac River, and the beavers up there were just enormous. I mean, I couldn't believe how large they were. And, it's always made an impression on me. But, in addition to that, we had some beavers on our property in East Texas, and they were kind of, they were returning to that area. And I remember that I started thinking about, it's just, how do the beavers actually know how to design these dams? Because they're very complicated. Some of these structures, because there are multiple dams and all sorts of channels that they build and all that. What do we know about that?
Yeah, those are great questions. And first of all, beavers are huge. Like, that is shocking. It was shocking for me the first time I really saw beavers in person. They are 40 to 70 pounds on average. I think the record size beaver is 110 pounds, which is like human sized. But they're really, really big, and they're really hard workers. And so when they go out into the landscape to do their thing, dam building is instinctual. So beaver will try to build a dam, even if it's never seen another dam or another beaver in its life. But they can build a lot better dams if they stay home with their families for a couple of years and sort of practice with their parents. And so beavers form family units, and those family units do stay together for a while. The parents are monogamous pairs. They mate for life. Every year they have a couple of kits. The little babies, they stay home for 2 to 3 years, shadowing mom and dad, practicing building dams, and then they go off and do their own thing and become their own sort of independent beavers. And they'll build tons of dams. Multiple sort of structures together will make a beaver dam complex. They build their lodge, a different structure. They dig these canals, a different structure. Like, it's just an incredible amount of landscape engineering. And it feels like really impressive when you see them in person, because you don't necessarily realize how hard it is to build a beaver dam until you see this thing made out of sticks and mud and stones that's holding back tons of water.
And they have, for example, somebody who worked for a river management agency. They have dams that help regulate the level of the dam that they live in. And we have that too. And and theirs are more complex. And so I'm just always like, I'm looking at that and I'm thinking, so how do they know, how to build this upper dam to the specifications necessary? But then I guess they're probably modifying it all the time to change how much water is coming out and, increase it or decrease.
Yeah, they're very responsive to sort of the local flow conditions. If there's a lot of water coming in, they can dig canals to try to spread that water out more. If they're feeling like their home pond, which has the big primary dam, is being stressed out too much, they'll build those secondaries upstream and downstream, sort of buffer the water system. They evolution is not a kind teacher. And so they've had millions of years of failures as well with thinking about different dam designs and sort of complex structures. And the beavers that can respond the quickest to changing environmental conditions and that build the sturdiest, most flexible, most dynamic dams, those are the ones that we still have today.
So tell me more specifically about your research.
So my research, it was actually very inspired by that documentary. The most compelling visual I saw in it was this aerial image they showed of one of these beaver complexes in the middle of the deserts of Nevada. And it was just bright green and surrounded by super wilted, dead vegetation. And they said, this is, we're in the middle of a 4-year drought and everything is wilting and the cows are starving and everything's dying. The fish are dying except here in this beaver complex. And I was like, I need to know about that beaver complex. So I actually studied that specific complex from that documentary from my very first study to see how much greener did this area stay during droughts than the rest of the landscape. So that sort of launched me into this trajectory of beavers and climate disturbances, beavers and sort of excessively hot and dry conditions. And at that point, I found that, it stayed way, way greener. And then it sort of followed for me living in the American West at the time, hearing about wildfires every year. The news is always like, well, after a record-breaking drought, we're seeing a horrible fire season. So I was like, well, if these beaver complexes aren't being really affected by the drought the same way, are they going to burn the same way if a fire comes through? And that was the real kickoff into Smokey the Beaver, which is, can these beaver complexes actually stay green and resist burning during wildfires?
So I love catchy titles for journal articles. I have 2 that were, I think pretty good. But Smokey the Beaver is my new favorite. And your co-author there, I guess, Andrew Whittle. Just want to make sure I mention him. And so when I saw this article, so I spend a lot of time up in Northwest Montana, and of course, there are wildfires every year, at least the threat of them. And now here we are, or here I am, back in Austin. We now have significant wildfire threats here. And, we probably had them in the past, but they're more acute because of climate change and changes in the landscape that have taken place over time here in Texas. And so, tell us more about the beaver's role in changing that cycle, or maybe, interrupting or influencing the wildfire cycle.
Yeah, so it might seem kind of silly to think about a beaver fighting wildfires. But I think a lot of that comes back to the fact that beavers work at scale. So it's not like one beaver is going to stop us from having wildfires plaguing California every single year, or Austin or Montana or anywhere. But when you have beavers spread throughout a watershed or throughout a landscape, every single one is going to build multiple dams. It's going to dig a lot of canals. And that's going to store water in the landscape and slow it down. So when we do have our rainy season or our snowy season and snow melt, that water doesn't just go rushing through the landscape immediately. It's hitting all these little speed bumps along the way. And that's really important when we have these incredibly hot and dry summers and increasingly hot and dry autumns, which really ups our fire risk. Because a lot of the fire risk, it's coming from dry vegetation. The plants have run out of water. We don't irrigate the forests the way we irrigate our croplands. And so they dry up and they become kindling and fuel. When you have all these beavers in the landscape, the water isn't done flowing in July or August like maybe it would be without the beavers. It's still flowing. They're increasing that base flow into the autumn. They are providing water in the soil for all of these plants that they can still access, where it's relatively protected from evaporation stress. And so they are irrigating the watersheds in these more wild spaces that are less human influenced. And then when you do have fires start, if your landscape is more of a mosaic of highly flammable and less flammable materials, you will still have fire, but it's not going to be these, mega fires and gigafires that go from a couple thousand acres to 100,000 within a week and just destroy everything in their path. It'll be much more of a natural fire regime. When you think about how many beavers we used to have in North America, it was like 100 to 400 million beavers. And for perspective, today we're somewhere in the 15 to 30 million range. So there used to be about a beaver for every single kilometer of habitable stream. They were everywhere. They were like squirrels or something. And because of all the trapping and the massive influence that we've had on the hydrologic cycle, we have a lot fewer, which means we have a lot fewer wetlands. And those wetlands, those are those sponges we need to keep the landscape from being so flammable.
Right. So, I read at some point that, beavers were drove the pre-colonial economy for some time, because there was just such a craze in Europe for beaver furs. And, I'm sure that's partly when the population was decimated. You mentioned that they're coming back some. So I've, thought about this some in my own research when I was doing my dissertation 22 years ago, having to do with the habitats here and what they might have been like when beavers were here, which they were, and they're now returning. But in areas that still don't have many, where we're concerned about recharge aquifers here, things like that. I was thinking about that and kind of concluded that, maybe some of those systems were less flashy because, you get big recharge events today and the water just goes over the recharge zone and goes downstream. But, back then with beaver dams upstream, you might have had more of a constant recharge because some water would be held upstream in those riparian areas and then released slowly over time.
Yeah, absolutely. And typically beavers would prefer to build their dams up towards the headwaters, which would actually magnify that effect, because when they're up in the headwaters, those are these little bitty streams where they're just kind of pooling that water, and then it can slow down, it can go into the soil up there, it can do, if you're in the mountains, like mountain block recharge and get all the way back down into those aquifers, and then maybe return to the river downstream. Like it's not necessarily lost forever into groundwater. There's probably a lot more springs back when we had a lot healthier hydrologic cycle than today.
Right. And, that jogs my memory about something, your first beaver dam that you're doing research on. I was kind of wondering, is that associated with a spring?
So the ones in Nevada, they were on Susie and Maggie Creeks, which are connected to small mountains. And so there's some amount of runoff that comes from that. But these creeks in their recent history had been very, very intermittent in their flowing. And a lot of that was because of groundwater extraction in the area. And then it was also really heavily overgrazed. And the ranchers and those creeks, they actually drove this restoration effort. And they're like, we're going to do some prescribed grazing, and we're not going to, this isn't working. We're running out of grass. We're running out of water. And as soon as they started doing that, these streams really sprung back to life. We saw massive groundwater recharge. There was, I think, centimeters of increase in the water table height every single year. And it totally bloomed back into the system. So I think there is, in that site, some source water coming from the hill slopes that was helpful to the system. But the groundwater component was really big based on how much of a change they saw as soon as it raised back up just a little bit.
So, we're very focused these days, and this is certainly good news, I think, on watershed restoration. And so what kind of role do you think beavers play in terms of water quality and, maybe flood mitigation? Because you've already mentioned wetlands. Yeah,
they definitely play an important role. Beaver ponds are these really nice slow water environments that are highly engineered by a beaver. So they're free to have in the landscape. They will really increase the sedimentation rate in a lot of places. And when you have certain agricultural pollutants or other like mine pollutants in the water system, there's been some really interesting studies showing that these pollutants can be settled out and then processed in the soil by different microbes. So it's kind of like a big Brita filter for your water. You put some pretty gnarly water in, and downstream, a little bit better water comes out. And every single beaver dam you have is going to increase that effect. They're definitely looking like they're very additive in the science that's been done on it so far. And every year, I swear, a new paper comes out that blows my mind in this sort of water quality realm. And a couple years ago, it was that there's like super, super nitrate laden water coming into these beaver ponds. And you go through the complex, and by the time you're out of the complex, there's no sign of excess nitrates. And they're basically preventing algal blooms. And then this year, a paper came out where it was these abandoned mines in Colorado that were leaking heavy metals into the water. And after it gets through the beaver complex, most of the metals have been filtered out, and they're in the sediments, where they can be managed a lot more easily than when they're suspended in the water column. And then there's another one I saw at a conference where there's, again, acid mine drainage, and the pH is like lemon juice coming out of this mine. And then as it goes to the beaver complex, by the time it's done, we're back at pH 7. So from a water quality perspective, there's so much that they're doing. And I think there's a lot more research to be done, because we're just scraping the surface. It's a big difference when you have fast flowing streams with little connection to the soil microbiome and community versus these wetlands that have really dynamic soils and all sorts of weird biogeochemistry happening. Like, what can that deal with, especially in the human context? Because we've put a lot of strange things in the water. So what can the beaver ponds deal with, and how much can they deal with? Because they're not an infinite sponge. At some point, I assume there's a threshold where these beavers will either abandon the site or be negatively influenced by those contaminants.
So you mentioned that after, I guess maybe having 100 million or so beavers, we went way down, and we're now back up to maybe 15 to 30 million. How are they distributed across the United States? Are there still large areas that used to have beavers that don't have them anymore?
Yeah, absolutely. Their distribution is very, very patchy. And part of that's because beavers and people like to live in the same areas. So as the beaver population starts to rebound, they want to go live along rivers and along streams, which is also where people like to live and where we've built our roads. And so some beavers are having a hard time getting back into some of their ancestral watersheds because we're there and we're not letting them build there with us. They're doing better, in my experience, in more sort of public lands and open space type lands where they're not in conflict with people. But historically, there were tons of beavers in the Sacramento River Delta. And today, there's not. And they could refill that habitat. But I mean, at this point, the Sacramento is so changed. It'd be interesting to see what they could do with it. But we're not seeing that because we are preventing them from fully reestablishing in that capacity. So while they are growing in population, they're not necessarily distributing themselves the way that they were, 500 years ago.
So every once in a while, there's a story here in Central Texas about beaver showing up in on a river or on a creek, and no one's exactly sure where they came from. And my guess is that somebody's not out there introducing them, that it's natural. And I've just, it's kind of interesting to me, how they disperse themselves, because it seems like to some degree, it's not just, slowly enlarging the territory and they're all kind of in one area and they're just kind of building out that, they seem to have a little, was it wanderlust or whatever, they set off and find some new place that they want to live in.
Yeah, they disperse much more than they sort of slowly expand. And so in the yearlings, or those 2 to 3 year old beavers are ready to get kicked out and go start their own beaver lives, they will go upstream or downstream as much as they can to find a new suitable habitat that can be their own territory. And sometimes that means just traveling a few kilometers, but some radio-collared beavers or radio-tagged beavers, I don't think they actually have the right neck shape for collaring. They've been tagged going 10s to 100 kilometers in dispersal. They will go if they cannot find a site that they like and that they think is going to be successful. And that is a lot. And they prefer to stay in the water when they're dispersing because they are extraordinarily awkward on land. But if they have to go on land, they will. And so they can cross into a different watershed. They can cross roads. They can go out overland and be waddling across the landscape, trying to find themselves a new home. So you can get some really weird dispersion. The beavers I was talking about in Nevada, nobody knows for sure where they came from either, because the nearest real active beaver colony was a good, 50, 100 kilometers away. So where did these beavers come from? They just showed up in these creeks and then did all this work. So something drives them to go find these new habitats. They're somewhat of a territorial animal. They don't like to share their space with another beaver family, but their territories aren't huge. It's not like wolves or mountain lions. Their territories a kilometer or 2 on either side of their main pond. It's not gigantic, but they like to find their own new homes.
Huh. So when they disperse, is it usually a group of them that go, or is it just one of them heading off and then maybe another beaver shows up eventually and they're able to start, building a colony of beavers or something? Yeah,
it's solo. So they go head off into the wilderness on their own, and they will, if they find a site where they think it's a good site, the beavers will start trying to build the dam, especially the male beavers will start trying to establish a site. And then they wait and they hope that a dispersing female will come through and that she will pair up. Or sometimes you see it vice versa, and the dispersing female finds a really nice site and waits for a dispersing male to cross her path. They do build scent mounds and communicate via scent. So there's some amount of beaver text messaging going along on the river corridors as they move up and down.
Now say that again.
The scent mound part, or?
Yeah.
Now, so as they're moving up and down river corridors, they'll mark with scent. Beavers will communicate with scents. And so they'll build these little scent mounds on the riverbanks around the floodplain. And they will leave their smell, and you can tell by their smell, I guess, if they are a young male or a young female or what's going on. And so it's kind of like little beaver text messages along the rivers. So when you're a dispersing juvenile coming through, you can tell oh, a dispersing female has been here. Oh, a dispersing male has been here. And then they got to cross paths and find each other because it's, they're very much alone when they're dispersing.
Huh. So, well, I kind of going back to, watching Jeremiah Jones. He's out there trying to catch a beaver, and he's got beaver scent. And so I was, always kind of wondering about that. I guess the beavers are always looking for other beavers, and, that brings them to those traps. Mm-hmm. Kind of thinking about that a little more, I mean, is there a good argument for, trying to distribute beavers? I mean, thinking about, issues that we're having with, as we mentioned, fire and water quality and flooding, is there a policy that might be considered in terms of our watershed management activities? Would they benefit from an effort to try to reintroduce beavers in a lot of different places?
I think they would. I think there's a few different ways you can go about doing that, and it's going to be really context dependent what's the most effective. In some places, if you have an established beaver colony nearby, your best chance for success is to build what are called beaver dam analogs, or fake beaver dams that people build, and sort of start that process for them in the hopes that a dispersing juvenile will see it and be like, this is a terrible beaver dam, but I can fix it, and then settle into that space. Because when a beaver chooses to go somewhere, that is its highest chance of success. However, there are places where there is no established beaver colony nearby. It is definitely within the beaver's historic habitat, and you really want to get beavers back into that habitat. Those situations, in my opinion, are a very good candidate for strategic relocation, because we also have beavers like in the Sacramento River Delta and in Denver and in cities where they are not coexisting well with people. And those beavers are on like beaver death row. They're going to be lethally trapped. They're not going to be allowed to stay in the system for whatever reason. And those beavers, you can move them. It is not easy to move them because you have to move the whole family, or it's a pretty low chance of success. And you don't want to have them sort of in the moving process for a long time, because that's going to stress them out. And that's also a lower chance of success. But beaver relocation has been done extremely successfully in a number of places, especially up in the Pacific Northwest and in Eastern Washington and Oregon. There have been some really strong cases of beaver relocation where beavers are taken from high conflict areas and put into places that want them and want to support them. And then those people that sort of received the beavers, they have all these wonderful drought and fire benefits. And the people that wanted to get rid of the beavers don't have to worry about their trees getting chewed or their basements flooded or whatever the issue was.
So you just touched on the, I guess there's some issues in terms of relocation, that it's not easy to get them relocated. And you mentioned that the entire family has to go. So if the entire family doesn't go, do the beavers that are moved, they try to get back to where they were, or they go looking for their family members, or what's going on there?
It kind of depends on which family members you get. If you lose one of the parents, it's going to be a pretty low chance of success. They're very much like a family unit, and the mom beaver and the dad beaver split the work. And so separating them, that means that each one is now going to have to be trying to do the work of two beavers. And if they have kits, there's no way they're going to be able to take care of their kits and take care of themselves and build a new home and all of that. So that's not good when you don't have both parents. If you leave behind kits, the kits aren't going to be able to survive on their own. They're very vulnerable when they're young. Same with yearlings that aren't quite ready to disperse. If they're not ready to go be a grown-up beaver, they're not going to make it without that sort of extra help from mom and dad. I don't know that they necessarily try to find their old family members, but it's kind of like people. Like, we have our routines, we have everything we know. And if you just like went into somebody's house and took 3/4 of the family and then put them somewhere totally new, everyone's going to have a bad time. Like, that's not good. But if you can get the whole family and put them somewhere new, at least there's that element that is the same. Like, they can still have the one that's really good at dam building, the one that's really good at going and picking willow for people to all eat. They can sort of build on that amount of skill and consistency that's already existing and rebuild their home around themselves.
So are you saying that they they have specialization within their groups?
Well, kind of. It depends on what time of the year it is, because if the kits were just born, then the mom beaver is pretty much in the lodge with the kits most of the time, feeding them. And so during that time, when the babies are there, it is mostly dad beaver and the yearlings that are out doing the dam repair and doing the food harvesting. When the kits are a little bit older, they're all out doing it, like mom beaver, dad beaver, everybody chews down trees, everybody works on the dam. But during that window of child rearing, there is much more specialization happening.
So, of course, we have to talk about the parachuting beavers of the 1940s. So tell us all about it. I'm sure you know that story better than most people.
I do, and I have a parachuting beaver on a hat and a sweatshirt. It's a great story. So in Idaho's the most famous example, but this also happened in California, I believe, and possibly other states that just haven't owned up to it yet. There were a bunch of surplus parachutes from the war, and there were a bunch of beavers that were starting to creep into more residential areas, and it was stressing people out. And there was also a desire to do some restoration in more wild lands. So they had this idea that became very famous from Idaho Fish and Game, who was so proud of it that they recorded like this whole little documentary video on it you can watch on YouTube. They would catch beavers from the high conflict areas, and then they would pack them into boxes and then put a parachute on the box and then push it out of an airplane, and it would land, and the box opens and the beaver waddles out, and it's supposed to start building and having its life. And they say they had very high success with that, which is possible. I mean, they did put a lot of time and thought and effort into this project. And the first beaver that they dropped him like 15 times to test it. And this poor beaver, he's just airplane ride after airplane ride. How disturbing if you are like a semi-aquatic mammal. But he was fine. And they ultimately released him, and he went off on his beaver life. And apparently he established a dam in the colony. But so they did this as a relocation effort. And it was one of the ways that they thought would help you get beavers from more urban areas into more rural areas. And you can do that. You can also do it with trucks and stuff, or ATVs, yeah. But it was fascinating. And I just love their like documentary. They're like, off she goes into mountain meadows. It was so bizarre. It's kind of like an icon now, though. It's like, look, people have been thinking about this for like 80 years. We've been trying to relocate beavers. What is taking so long with figuring out how to support this keystone species as it like tries to reclaim some of its ancestral lands?
Well, that's what I was going to ask you about. I mean, so people have been thinking about the benefits of beavers in these systems for that long. Which, that was one of the things that kind of shocked me because, it's like, okay, well, if they just had nuisance beavers, the old techniques that they used to use for nuisance animals, were pretty cheap and easy to do. But here they are, parachuting beavers into, areas that they weren't living in. And so obviously they knew somebody at some point figured this out, I guess, initially that, hey, they have benefits. And so I'm just curious about that. I mean, do you know anything about that old research?
Yeah, it's weird with beaver science. I mean, the knowledge that beavers are responsible for creating and maintaining entire ecosystems dates back thousands of years in North America. This is well known by many different indigenous peoples, and it has just really been ignored for a long time. And then the European fur trade really pushed this creature to near extinction. And as they come back, they've gone through these waves of like good PR and then bad PR and good PR and bad PR. And it's like, oh, beavers are doing so great. In the early 1900s, just as they start rebounding, all these naturalists are saying like, this is amazing. Did you know this creature can build a dam and it's huge? And then someone's like, yeah, but did you know that dam is full of mud and mud can kill fish? And it's like, can it? And then they're like, beavers are bad. And then they're like, no, actually, they make this really great fish habitat. And it's like, oh, beavers are good. And then it's like, oh, but what about, they chew down trees. Uh-oh, beavers are bad. And I think people really are just struggling to understand that this is a creature that can have a really large influence on the landscape and that we can't control it. And that makes it hard for people to want to accept it because you just kind of have to sit back and let them do their thing and see what's happening. And the happenings are very dramatic. Like they do chew down trees, they do flood things, they do dig canals, they do change streams into whole wetlands. And I think beaver science is finally reaching a point where we're thinking about them in a larger context. It's not the single pond scale anymore where it's like, oh, did you know the beaver builds a dam? We're like, oh, what does it mean if a whole watershed is full of beavers? Like, what does that do to the hydrologic cycle? And I think we're also getting a little more comfortable thinking about them as a creature that can have a really disproportionately large impact on the system. It's like until I think it's the early 1700s, beavers had a larger landscape impact in North America than humans did. Like they were working on this land. And it's just like, I think beaver science has had its ups and downs, and it's hard to get people to sit at the table and say like, yes, I am going to turn over this 100-acre parcel of land to a colony of 100-pound rodents, and I will let them do what they're going to do, and I'm not going to interfere. Because I mean, it's a big ask, but it's probably the right thing to do in a lot of places.
Well, I've read a few things lately that talk about the benefits of beaver dams and to trout. And, if the trout fishermen decide, hey, beavers are good, that'll go a long way to helping out in terms of, getting money and convincing landowners to maybe give beavers, a little space on their property.
Absolutely. I think in animal conservation science, a lot of times people come up with these stereotypes in their minds about who supports animals and who doesn't. But in my experience within beaver conservation and beaver restoration, the biggest supporters and allies are the hunters and the fishers and the trappers and all of these people who are out there in the land. Like one of the best conversations I had was with a very enthusiastic duck hunter. And he was like, I absolutely love beaver ponds. Do you know how many ducks are in these beaver ponds? Like it's amazing. And like there's this recognition, like this animal creates a whole ecosystem. And if you like catching big fat trout, you want to go to the beaver ponds. That's where they're hanging out because that's where the food is and the slow water is. And I've really loved working with all those groups. I find them incredibly intelligent and knowledgeable, and they can always tell me where the nearest beaver dam is.
That's great. That's great. So you're going to have to send me a photo of this shirt with the parachuting beaver on it. I'll try to put that, up on social media when your podcast episode is published. I think later this week or maybe next week. So let's go to our last question. So how can our listeners learn more about your research?
There's a few ways you can learn more about my research. One, if you use social media, I have a Twitter account that's just a nonstop stream of different beaver science, and it's at Emily Fairfax, so that should be pretty easy. I also have a professional website, emilyfairfaxscience.com, and that is updated periodically. Probably could be more frequent. But I do have TLDR, or too long didn't read, summaries of my papers on there. So if you don't want to read the whole thing, which I won't take offense to, they can be kind of long, you can at least get the highlights from those and see some cool pictures. You can also, if you just Google my name, you'll probably be able to find a few of my appearances in PBS and different magazines where I talk about beavers, and that's where I share a lot of my cool pictures. So you can always find my research somehow. And you can also email me if you're like, I have to talk about beavers. Like, definitely email me. My contact info is all over my website, and I'm always happy to chat about them.
That's great. That's great. I bet kids just are really fascinated with your research when they hear about it.
They do. They love it. And they always have the best stories to tell me about when they saw all different things in the ponds, or when they stepped in the mud and they sunk up to their knees like quicksand. And I'm like, yeah, isn't it cool?
Oh my gosh. I did that, sank up to my waist, and my dad sank up to his knees trying to pull me out. And then another dad was sinking, to pull him out. And so, yeah.
It's a lot. It's pretty squishy mud out there.
It is. It is. Emily, this has been great. Thank you for joining us.
Yeah, absolutely. I'm always happy to talk about this stuff.
This has been Talk+Water. My guest today was Dr. Emily Fairfax, who is an assistant professor at California State University, Channel Islands. Dr. Fairfax's current research is focused on beaver dams and their hydrologic and geomorphic impacts. I want to thank our listeners for tuning in, and to say that if you enjoyed this episode of Talk+Water, please consider giving a like. My name is Todd Votteler. Let's talk water again soon.